y equals x minus 3 times x squared minus 4. I can set each of those factors equal to 0. Now, I'm going to pause for a second before I set this factor equal to 0 and show you what we would do with that, even though you already really know. And I want to point this out. We've always said that we're going to set the factors equal to 0. But there's never anything in math that's just magical. Okay? We all know that a 0 is called a 0 because what is 0? The y. Because remember, a 0 is connected to the x-intercept, right? And that's I know it's confusing because the x can be 0, the y can be 0, but it's called a 0 because the y can equal 0. So really, we're not starting off with the factors equal to 0. Really, it's just 0 is equal to x minus 3 times x squared minus 4. That's what we really have at the beginning. So how do we magically just make the factors equal to 0? Miss Courtney actually touched on this yesterday within the lesson. And this is an important detail, and there are 3 words that you need to pay attention to because they will show up throughout mathematics. I want to point this out. Pointing this out from here, if I have A times B times C equals 0, what do you know about either A, B, C, or some combination?
1 over 0.
At least one of them has to be 0, right? The only way to get 3 numbers multiplied together to equal 0 is one of them is 0. This is the 0 product property. This is in the textbook, and it is on your graphic organizer, and you need to pay attention to it. The whole idea is, if you have any numbers multiplied together that equal 0, one of those factors has to be a 0. So if A times B times C equals 0, then at least, notice how I say at least, because could it be more than one that's 0? Yeah, it could be 5 times 0 times 0. It could be 0 times 0 times 0, right? At least one factor is 0. The 0 product property tells us, hey, if we're multiplying factors and they equal 0, at least one of those factors has to be 0. So applying it into this beautiful case, do we have factors? Yes, Mr. Kenny. Thanks, guys. Yeah, we got factors right there. So at least one of those factors has to equal what?
0.
That's it. At least one of those factors has to equal 0. So x minus 3 is equal to 0. We've solved it. Boom, done. Well then, also x squared minus 4 is equal to 0. What would I do to solve this? Plus 4 on both sides. Create that 0 there. X squared equals 4. And then square root. So what does x equal? Sure? Yeah? Let me ask you all a question. How many zeros am I supposed to have?
2 and 2.
Well, pause on that for 1 second. But how many zeros am I supposed to have? At least how many? Well, I mean, look at the degree. I gotta have at least 3, right? Here's 1. If I say just 2, that's only 2. The other one is negative 2. Do I have all 3 of mine now? So, this is why I say that it just has to be the factors. Notice that could be a quadratic factor. Think it might be able to be a cubic factor?
Yes, sir.
Heck yeah. Right? It could be any factor. It's just those factors have to equal 0. Right, Jaquan? Come on, pull that hoodie down. You can't be falling asleep in my class. I want you to learn and grow. You'll be the best mathematician you can be. At least for the next 45 minutes. Alright, what are your questions before we continue? I know, look, I know it's not as fun as us talking and engaging, and it's usually what I want, but we gotta cover some things based on these understanding checks. We missed some details. Alright, who struggled on domain and range?
Me.
I did.
I
I
did
did good on everything else.
So, do we need to define that domain and range?
Yes.
Maybe a couple of these other details?
Yes, the whole problem.
So, someone give me an explanation about domain.
Something to do with the eggs.
Something to do with the x. Anything else to add? Or want to push back on? Okay, so I will agree. Now I want to clarify. It does deal with infinity sometimes. And in this problem, the domain is negative infinity to infinity. And that's how we would write it. We'll talk more about all those details in a second. But remember, the final answer is not going to help you if you don't understand why. Right? Because that's not always the case. So domain.
Why you put negative infinity?
We're about to talk about it. So remember, Jake, I was just saying that that's the final answer here. We're going to go into detail with this pretty heavily. The domain is not just the x values. If you say just the x values, that implies it's only some of them. The domain is the set of all x values. For the graph. But I'm going to add on to that because our function's only seen in graphs. No. X values in domain are also called, and it starts with an I.
Intervals.
Not intervals. Okay. What could I do with this x? I could plug something in, so they're also called inputs. They can be integers, but they can also be decimals. Look right here. That's definitely not 0 or 1, right? That's a decimal. So it's all possible inputs for the function. And so we're going to look at both of those ideas with this problem to build that better understanding. So don't write this part down. This is just to help build a contrast because I saw a misunderstanding in the first block. To start here, tell me, is there anything I cannot substitute in for x in that square root function? There's a whole bunch of numbers. Which numbers? Say it louder. I can't take the square root of a negative, at least not yet. We'll learn about that next unit. You actually can take the square root of pi. Pick up that calculator. Take that square root of pi. It's going to be ugly. It's going to be an irrational number. What's the square root of pi, roughly? 1.7 something? And it's got a whole bunch of decimals after it? Yeah. So can you take the square root of pi? Yes. Right? You can take the square root of any positive number. You cannot take the square root of a negative. Okay? So that would affect the domain because there's a whole bunch of inputs I cannot put in. Actually, what would be the lowest value you could put in? 0. You can take the square root of 0, right? That would be my lowest x value. That's the lowest thing I can plug in. What's the highest value I can take the square root of? So infinity is not really a number we can take the square root of, but there's no limit. That's why we write infinity. I'm going to come back to this in a second. This is a function we have not looked at yet. It's called the reciprocal function. Does anyone know any values that I cannot divide by? You can do a decimal, so 1 divided by 0.5, that would be 2. But tell me this, what's 1 divided by 0? You get a syntax error, and it's not like, oh, it is syntax error, it's an error. I don't know if that's actually what it puts in. What does it kick out?
Error.
It just says error? It says undefined. I would say, I think, if you put in these calculators, that's going to tell you undefined. That is actually something that we do not know in mathematics. Notice it doesn't say it doesn't work. It says we don't know what it is. It's undefined in mathematics. So you can actually plug anything else in. So the domain for this would be every number except 0. Taking all that background, what is a number I cannot plug into this equation or substitute in? Can I do 0?
No.
I can't substitute 0 in and get a number out?
Yeah.
I can. Look at the graph right here. If I put in a 0, what do I get out? 0. So that's a good thought. I love the guess, right? But we make guesses, we check them, right? We're looking for patterns and relationships. Any other predictions about a number I cannot plug in? Negative 1? So I'm putting negative 1 in place of x. You think I could plug that into a calculator and get a number out?
Yeah.
Notice right here, J1 is a great guess, but there's a negative 1, right? And the graph is going to continue going down, isn't it? So there's some point down here that would have an x value of negative 1. I just don't know what the y value is yet based on that graph, but I could do it. Any other guesses?
Couldn't you plug anything in? Because it's negative infinity to infinity.
Remember how we earlier said the domain was negative infinity to infinity? Polynomials, you can always plug in any number. Because there's no restrictions, right? I cannot take the square root of a negative. I just can't. That's why that's the domain. I cannot divide by 0. That's why 0 is not in the domain. But I could multiply by any number there's ever been. Does that make sense? Okay, Jake1's like, no, Mr. Kinney. But understand, that's only looking at it from the input side. A lot of us will struggle just looking at an equation to define the domain. But look at it this way. Domain, is that horizontal or is that vertical?
Horizontal.
That's horizontal because I'm talking about the x values. It's not drawn on there because it's all from the calculator, but haven't we always drawn an arrow? Which means that this function is going to keep going down. But we don't care about down right now. We're talking about domain. It's going down, but it's also going to the... Is it ever going to stop going to the left?
No.
So what is the lowest x value that this function can have? You see how that graph agrees with what we just discussed, that we can plug in any number. Over here on the right side, it's not drawn, but we understand there's an arrow, meaning it's going up, but it's also going to the...
Right.
So what's the maximum x value? Infinity. This is what we mean. Does anyone remember the name of this notation, by the way? So the infinity are the numbers, they're not really numbers, but those things right there. But I'm talking about this whole notation.
What did it start with?
It does start with an I. So what I would point out is, what we are looking at is the interval from negative infinity to infinity.
Wow.
So the notation is
Interval.
interval notation.
Alright.
That's called interval notation. Again,
It always come back around.
it is a notation with an interval. Literally what we mean by that is, it's everything from the minimum to the maximum. Everything, right? That's what that comma is. So you always do interval notation from a minimum
What interval mean?
to a maximum. So, that's a good question. If I were to just graph these points right here,
Well, I see.
hold on. You see those points just graphed right there, KT? So those are called discrete points. They are just isolated points, right? But if we have something that's continuous, meaning it's not just individual points, something like this, that's known as an interval because it hits everything in between, right? So whenever you have an interval, it's hitting everything in between.
Oh, okay.
So it's hitting everything in between negative infinity to infinity. Does that clarify that question enough that you understand?
Yeah.
Okay. What are your questions before I continue?
thought, though.
That's not what you thought it was?
I would like to see a situation where it would be negative infinity to infinity. Like, what would I mean? Oh, that, okay.
You're good. But remember, we actually did this function already a couple times, right? And I like the question, so I'm going to answer it. So remember, this is the function for the square root. Right? The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. That's how I'm using my inputs to get my outputs. Square root of 9 is 3. So what is the lowest x value that we can use? Huh? Lowest x value is 0. Notice how for the domain it's going to continue to the right. So is it ever going to stop? So what's the maximum x value? And remember, that's what we said just looking at the equation. Because we knew that we couldn't take the square root of a negative. The lowest x was 0. The maximum went all the way to positive infinity. You can look at equations and at graphs to figure it out. 1 divided by the square root of x. Y'all have not looked at this yet, so I'm just going to sketch it out. It looks like this and like this. Notice how it's approaching the y-axis. It never actually gets there. But notice it's going to go all the way from negative infinity. It has everything up here, but what's it missing? What's this x value? So remember, I need the domain, the x. What is the x value on the y-axis? 0, right? So comma 0. And then what, we're not going to get into it right now, but you put a u here to indicate it goes together. But notice how it has, you see how this is going all the way up to 0 as well in the x? So we would start back at 0 and go all the way to infinity. One thing to clarify, oh, and I haven't talked about this yet. A bracket like this means that that value can be included or equaled. Okay? So can we take the square root of 0? Yes, which is why I use a bracket there. This parenthesis means that that function cannot equal that value. Right? Which is why every time we've seen an infinity, what have we put? Parenthesis, right? And so we put a parenthesis to indicate that that value cannot be equaled. Can this function ever have the x value of 0? That's why it only breaks at 0. Okay. Does that help you see the domain a little bit better?
Mm-hmm.
Okay. Who else lied? Huh? You will see rational functions on the ACT list. Not every time, but sometimes. Okay, range. Based on everything we just talked about with domain, what do you think the range is?
Why?
How dare you? Be clear. Be convincing with your understanding. The set of all y values for the target whining. Just kidding, make one. I like. All right, say set of all y values for the graph. So how else could I say that? All possible. Which one? Outputs. Remember, those outputs depend on the inputs, but the y values are my outputs for the function. Keon, you've been a little quiet today. I need you getting engaged. Any guesses what notation we're going to use for the range? None?
I know you got something there.
Come on now.
Not even trying.
Come on.
Not even trying. Liam's calling you out on this. Come on, think about what we talked about with domain. How are we going to talk about that range? I can't say anything. I don't try either. At least you're self-aware. What notation are we going to use to indicate the range of f of x? The correct notation.
Come on, Keon.
Do you want to see if someone else has an idea?
Can I say it's not going to be interval notation?
It's not going to be?
Okay, you on the right
That's what I
track.
think.
Oh, it is going to be interval.
I don't think it's.
You don't think it's going to be interval? Okay. Chloe, what were you thinking?
She said,
I was asking if it was also gonna be interval.
Maybe interval notation? Okay, so let me ask y'all this. What do you think the lowest y value is, right? We're talking about range. Look at that graph. What's the lowest y value for that graph? I want you to notice, right? It's going to keep going down, isn't it? To negative infinity. What do you think the highest y value will be?
Positive.
It's going to keep going up, right? Do I have every y value in between?
Yes, sir.
So do I have an interval of numbers?
Yes, sir.
So what am I going to use? Interval notation. Interval notation is just a way to represent things. It's not just for domain or just for range. We're actually going to use it, oh look, intervals of increase. We're going to use it there too. Okay? So what is the minimum x or minimum y value?
Negative.
Maximum?
Infinity.
So again, you always want to do the minimum first and then the maximum.
Come on with it, 5 minutes.
Whose class is this?
They must forgot.
They must forgot, that's what I'm saying. Yikes. So let's look at the square root of x function. What would be the range here?
Oh, we on that one? Okay, it's not going vertical, so.
It's not going vertical at all?
Oh, it is. No.
It would be.
Hold on, it keep going up.
It
So,
would be 0.
no.
Okay, so Liam thinks 0
Positive.
to positive infinity.
Yes.
What's the lowest y value?
0.
0. Will it ever quit going up?
No.
Notice it is going to the right, which is what you're thinking, but it's also going up, right?
I see it.
Uh-huh. Bracket or a parenthesis on that 0?
Right.
Bracket. It has the value of 0, right? Bracket or parenthesis on the infinity? Okay.
Would you take off points for understanding if we don't use brackets?
Yes.
Yes. Yeah.
Okay.
You gotta know whether that value can be equaled or not and indicate that.
Yes.
By the way, before y'all start thinking I'm crazy and running off to your English teachers or whatever, when you have 2, they're called parentheses. When it's 1, it's parenthesis.
Yeah, I was like, what are you?
I know.
English,
That comes from a Latin root.
Just like,
I'm
That's-
in the English lesson too.
just like,
I would prefer English lesson, to be honest.
Right? So, but Latin root words have that singular and plural. That's what it's coming from. Just so you're aware. Alrighty then. Questions, concerns, comments?
Y'all master here.
Mackenzie's like, no, I'm good, just kidding. Alright, you need to start talking, get those active collaboration points.
Collaborate.
Trying to help. Alright. So, intervals of increase and decrease. I need y'all to hear me clearly on this. If you color code things when it comes to increase and decrease, it's going to help you a lot. But I want to also clarify, because we forgot to include an important word here that most people don't, but I always want to include. It's not just an interval of increase, it is a domain
Okay.
interval of increase. Why would I include that word, and why should you pay attention to that word domain?
In the set of all.
Oh, I got some students paying attention, right? That domain refers to the
Wheel.
x values. Not that tired today. That's right, we're finally starting to pay attention and learn. Okay, so do not forget, right? Momar, when we look at a graph, we always read it from left to right. So as I move to the right along this function, what's it doing right now? It's increasing, right? It's going up. So tell me when it stops increasing. Just tell me when. Okay, right there? Okay. So what's it doing after it stops increasing? Okay, tell me when it stops decreasing.
Let me get to that right now.
What is that?
That is the minimum range.
Not just a minimum. Be careful. There's another word you're forgetting on the word minimum. Say it again. Relative.
Relative. I just did it last
Uh-huh. Because here's the thing. You see all these points right here? Do these y values have lower values than this one?
Correct.
So that's not what we call an absolute minimum. It's just a minimum for that area. It's minimum relative to what's around it. We're going to talk about that in a second. So what's it doing through here? It's increasing again. So how many intervals of domain intervals of increase should we have? How many domain intervals of decrease should we have? You see how the color coding might help us here? Whole lot, right? I've had other students, and again, yeah, you have markers, colored pencils, crayons, all that stuff in your boxes. If you want, I can always buy more, but, oh no, I still have some back there. But what I would also say is some students in the past have just circled this and wrote increase, and circled this and wrote decrease. That's great, right? That's evidence of your understanding. But once again, we gotta pay attention. Domain interval of increase. Start with that leftmost one. What is the minimum domain value that I would write for where it starts to increase? So remember, it's going to the right over here. 2.35, is that the minimum or maximum? That's the max x value. It starts decreasing all the way down here, and it's going all the way up, right? So, negative infinity, comma, why not 228?
So that's the y.
That's the y. I need the domain. One thing that a lot of students get confused on, because they always want to put the y. The fact that it's increasing tells me the y's are increasing. I want domain where the function increases. I want to know the x values over which that's happening. Okay? What's the other domain interval of increase then? 7.65 to what? Infinity. Now, it's infinity because it's going up, correct? Sure about that?
Yes.
I'm going to push back on that a little bit. Think about this again. It's a domain interval of increase. It's positive infinity, but it's not because it's just going up. It's going up and to the right. You've got to remember, yes, it's increasing up, but I need a domain value. I need a domain value. The infinity is because it's going to the right as it goes up. You've got to be careful about that. Okay?
I got a question about first negative 2.35. How do you get it?
You understand that first pink section? You see that first pink section that we did? Okay. So remember, I'm going from left to right. So all the way to the left, this function is increasing, right? Or as I go to the right, it's increasing. So what is the x value all the way over here where it starts to increase? Because remember, it's really like down here. So what is the lowest x value?
Negative infinity.
Right.
Okay.
And where does it stop?
2.5, okay.
There you go. Okay. So what about an interval of decrease?
How can you get it out?
Wouldn't you what? So first off, does anyone want to push back on that or ask a question about that? Yes, sir.
I would explain that, 'cause
Yeah.
How would you explain that?
I put those points and you just put Y question mark.
Correct. How would you clarify that?
Yeah.
You woke up on 21.
So, I know, right? So, first off, this color coding here can help with it, right? And so, you could very easily, so why do we know this? Well, that is the lowest x value when function starts decreasing. And then this is where it stops decreasing, right? Just tell me why. Right? And I will clarify and point out, whenever we say where on a graph, we're talking about the x values. Anytime I say where, I'm talking about x or domain.
Teachers, excuse
Says something
the
to be aware of.
interruption, this is an all call.
No.
Any student that is participating in the choir's SCPA needs to report to the choir at this time. Thank you.
Okay. We all good with that? Questions, concerns, comments? Do we have a better understanding? Quick thumbs up if we feel like we have a better understanding than all.
Is that everything something?
As with
When you wrote the lowest x value?
It's just a short.
lowest x value when Oh, function,
Oh,
fxn.
It's a
okay.
shorthand version.
Yes, thank you. fxn is a shorthand version for function. Okay, quick thumbs up if we're feeling better about this. Understanding? Getting some? Jakeem, was that a nod, or you didn't show me the thumb? You are feeling better? Alright, Jaquan's feeling great about it.
That boy is slow.
I know. Alright. X-intercepts, Y-intercepts. Need y'all to pay attention to this. I saw a lot of people say this. Or just 069.
Good luck to you, please.
By the video will be up if you need the last 20 minutes or so of this.
Okay.
Okay. If you did this, you didn't get a whole lot of credit.
There's zeros, not x-intercepts.
Those are zeros. And now are those zeros connected to the x-intercepts? Yes, but how do we always write x-intercepts? As a point, right. So I needed 0, 0, 6, 0, and 9, 0, and 0, 0. You still needed to justify, how did we know the x-intercepts? How did we know? That's where the function. So like if you even drew those points, I acknowledge that as some justification. But what should you tell me about why you know those are the x-intercepts?
That's where the function crosses the x-axis.
Thank you. It's where the function intersects the x-axis, right? And then we will, if you're paying attention to that, similarly with the y-intercept, oh yeah, it's just where the function intersects the y-axis. It just so happened to also be an x-intercept. He's a great note taker. Jesus, did I answer your question earlier?
I was in that
Okay, if you remember the question, let me know. Alright.
They took my paper.
Such hostility.
You don't know great.
It don't feel like that.
Alright. Relative maximum. Anyone know? What we should write here, or what the answer might be? Say again. Okay, so say again. Kind of. I'm not going to write it as a point, so I'm going to talk about it in a second. And what Caleb is saying is pretty accurate. Keyshawn, did you want to say something? No. Okay. So the way that it's worded in the book, and the way that I would say it every single time is, it is the maximum, and so I'm going to say not point, but value for that section of the function. It doesn't have to be the highest overall, but it needs to be the highest for that little area. Now, there's a way easier way to identify a maximum, though. It is where the function, notice the where, that's the x part of it. So you want both the value is the output, the where is the input. But this is where the function stops something and starts